Here's some help with the homework. You can just fast forward to whichever ones you need. Number 1A, we have a quadratic in disguise. Let's get everything over to one side and see if we can factor it. So we have 2 cosine squared theta minus cosine theta minus 1 equals 0. Okay, so this does factor into 2 cosine theta plus 1 times cosine theta minus 1. Set each factor equal to 0. 2 cosine theta plus 1 equals 0. Cosine theta minus 1 equals 0. Solve each equation. So with the first one, we subtract 1 from both sides and divide by 2. So cosine theta equals negative 1/2. Then we take the inverse cosine. So theta is the inverse cosine of negative 1/2. Now we think about what this means. So where is cosine negative? Cosine is negative in quadrant 2 and quadrant 3. So we could draw a reference triangle in quadrant 2 and a reference triangle in quadrant 3. Cosine is adjacent over hypotenuse, so the adjacent is 1 or negative 1, and the hypotenuse is 2. So we know that means that our opposite side is square root 3. So we know that we have a 60-degree reference angle. So in radians, well, first in degrees, our answers are 120, excuse me, 120 degrees and 240 degrees. And in radians, those would be 2 pi over 3 radians and 4 pi over 3 radians. So there we have 2 of our answers. And now we go back to the other equation, and we add 1 to both sides, and then take the inverse cosine. So the inverse cosine of 1 means the angle whose cosine is 1, and we know that to be our favorite quadrantal angle, 0 radians, and so theta is 0. So we have 3 answers, 0 and 2 pi over 3 and 4 pi over 3. Okay, number 1B. Both 1A and 1B are similar to lesson example number 1. And so this one is factorable as well. So we can factor it into 2 sine theta minus 1 times 2 sine theta minus 5. And set each factor equal to 0. 2 sine theta minus 1 equals 0. 2 sine theta minus 5 equals 0. Solve each one. So for the first one, add 1 to both sides and divide by 2. Sine theta equals 1/2. So theta is the inverse sine of 1/2. So that is positive 1/2. So we're in quadrant 1 for sine to be positive, and we're in quadrant 2 for sine to be positive. So 1 over 2, the opposite over the hypotenuse. So we know we have a 30-degree reference angle. So our angles are 30 and 150. And then putting those answers into radians, we have pi over 6 and 5 pi over 6. And now we go back to the other part, and we're going to add 5 to both sides and divide by 2. Do you know that sine cannot be 5/2? Because if you picture a sine function, how high does it go? How low does it go? It goes up to 1. It doesn't go up to 2.5. It goes down to negative 1. So this has no solutions. Also, you could put it in your calculator, and you're going to get an error message. Also, you could draw a reference triangle. You could put the 5 on the opposite and the 2 on the hypotenuse, and hopefully at that point you realize, so somewhere along the way, you're going to realize that this has no solutions. But we still do have the solutions that we got from the first half of the problem. Okay, let's take a look at number 2. So this one is not factorable, unfortunately. So we're going to use the quadratic formula. So we have the tangent of theta equals our a, b, and c are 2 and negative 1 and negative 2. So the opposite of b would be 1 over 2 times a would be 4. plus or minus the square root of b squared, 1, minus 4ac, so minus 4 times 2 times negative 2, over 2a over 4. So we get 1/4 plus or minus square root 17 over 4. And that is equal to tangent theta. So we have to take the inverse tangent of both of those numbers. Do them one at a time. Inverse tangent of 1/4 plus square root 14 over, or sorry, square root 17 over 4 is one of them. And then inverse tangent of 1/4 minus square root 17 over 4 is the other one. Okay, so let's go back to the first one. Put it in the calculator. Make sure your calculator's in radians and approximate. So we should get approximately 0.91 radians. And that is in quadrant 1. So let's picture this. Quadrant 1 angle, 0.91 radians. So then your other quadrant where tangent is positive is quadrant 3. So that triangle would also have a 0.91 radian angle, but these two are pi radians apart. They're half a circle apart. So to get the second answer, we have a first answer, we have our quadrant 1 answer. To get the second answer, take that quadrant 1 answer and add pi radians to it. And you get approximately 4.05 radians. And that would be your quadrant 3 answer. And then we move to the other equation that we neglected way up there. And we put that in the calculator and approximate it, and we get about negative 0.66 radians. So that would be in quadrant 4. That tells us we went 0.66 radians clockwise. So we have to write that as an answer between 0 and 2 pi. So we're going to add 2 pi radians to it. So negative 0.66 plus 2 pi takes us all the way around the circle and back to the same spot. And we get 5.62 radians. So that's our quadrant 4 answer. And then for our quadrant 2 answer, it's just half a circle away from that. So take the original negative 0.66 and add pi to it for adding half a circle. And you get approximately 2.48 radians. So we have our 4 answers. All 4 were approximate answers. Okay, let's move on to number 3. So this one is similar to notes example number 3, and it's another one where unfortunately we have a quadratic equation in disguise that is not factorable. So we're going to use the quadratic formula. So we have cosine theta equals the opposite of b, negative 2 over 2a, 4, plus or minus the square root of b squared, 4, minus 4ac, so minus 2 times negative 1, over 2 times a, which is 4. Okay, so let's simplify this, and we get negative 1/2 plus or minus square root 12 over 4. And that's going to reduce to, square root 12 is going to be 2 square root 3, and then we're going to reduce the 2 on the top and the 4 on the bottom, so we're going to have square root 3 over 2. So cosine theta is both of these numbers, and let's break this up into the one with the plus and the one with the minus and do the inverse cosine of them. So we have theta is inverse cosine of negative 1/2 plus square root 3 over 2. And also, theta is inverse cosine of negative 1 minus square root 3 over 2. Okay, so let's work on the first one. So we grab a calculator, we put this in the calculator, and we get approximately 1.20 radians, and that is a quadrant 1 answer. How do we know if I'm in quadrant 1? Well, remember that half a circle is pi, and so a quarter of a circle is pi over 2, and 3.14 divided by 2 is about 1.5 something. So if you're at 1.2, you're smaller than half of pi. Okay, so now this is our quadrant 1 answer. And where is cosine positive other than quadrant 1? That would be quadrant 4. And so we have a 1.20 radian angle going that way, and we would have a 1.20 radian angle going the other way. So what we can do is we can take the entire circle, which is 360, and subtract 1.20 from it. So the entire circle, 2 pi minus 1.20 radians, would give us approximately 5.08 radians. And that would be our quadrant 4 answer. So we have 5.08 and we have 1.20. Now let's go back up to the other equation. And when you put this in the calculator, you're going to get an error because this number is less than -1, and you can't have cosine go below -1, so this part has no solutions. Yay, we love that. We love no solutions, don't we? Because we're lazy Americans. By the way, speaking of lazy, I wanted to tell you guys, I've made up my mind. I'll do algebra, I'll do trig, I'll even do statistics, but graphing is where I draw the line. Okay, number 4. So this one is the kind where we have two different trig functions and we want to use an identity to substitute. So we're going to use this identity, cosine squared theta plus sine squared theta equals 1. And so what we could do is isolate cosine squared theta or isolate sine squared theta. It really doesn't matter. You just pick one and do it. So eeny, meeny, miny, mo, I'm going to isolate sine squared theta. So sine squared theta equals 1 minus cosine squared theta. So that means I'm going to replace my sine squared theta with 1 minus cosine squared theta. So now I have 3 cosine squared theta minus the quantity. These parentheses are vital to getting the signs correct in your next step. Minus the quantity, 1 minus cosine squared theta equals 2. Now we need to distribute this minus sign. So we have 3 cosine squared theta minus 1 plus cosine squared theta equals 2. Combine like terms, we have 4 cosine squared theta, add 1 to both sides, and we have equals 3. Divide both sides by 4, cosine squared theta equals 3/4. Square root both sides. Don't forget the plus or minus. Cosine theta equals plus or minus. You can square root the top and square root the bottom separately. Square root the top is square root 3, square root the bottom is 2. Now hopefully you recognize that we do know the angles that have a cosine value of square root 3 over 2. We can picture this. We have square root 3 on the adjacent, we have 2 on the hypotenuse, 1 on the opposite. This is a 30-degree angle. And because we want both plus and minus, we're going to be in all 4 quadrants. 30-degree reference angle in all 4 quadrants. So what are all of our 30s? In radians, we have pi over 6 for 30 degrees. We have 5 pi over 6 for 150 degrees. We have 7 pi over 6 for 210 degrees. And we have 11 pi over 6 for 330 degrees. That one wasn't too bad. We have one more. Number 5. Same idea here. We've got sine squareds, we have cosine squareds. Let's use the identity and substitute to get rid of one of them. This time, how about if I keep the sine squared thetas, because last time I kept the cosine squared thetas. So I'm going to write this as cosine squared theta equals 1 minus sine squared theta. And I'm going to remove my cosine squared theta and replace it with a 1 minus sine squared theta. Again, I have a subtraction sign in front of what I'm replacing, so I need parentheses around it. Distribute the negative. combine like terms, and we have 2 sine squared theta minus 1 equals 0. Add the 1 to both sides and divide by 2 and square root. And when we square root, don't forget the plus or minus, just like in problem number 4. And the square root of 1/2, once it's rationalized, is square root 2 over 2. So we have plus or minus square root 2 over 2. So theta will be the inverse sine of plus or minus square root 2 over 2. Hopefully we realize we know that one. We know that one. This is good. This is 45, right? In quadrant 1, it's 45 degrees. In quadrant 2, we want all the quadrants, don't we? Because we have the positive and the negative. So we have 45-degree reference triangles. 45 degrees, 135, 225, and 315. Express those as radians, and we have pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, very good. Homework is done.